Okay, here we go. So, the test. The test is coming up on next Wednesday. We probably won't finish this all up today, but we'll get through most of it. And then what we don't finish today, we can finish on Tuesday. You guys have done a great job this week, and just go ahead and take Monday off, and we'll give you a long weekend and come back ready to go on Tuesday. We got that out.
I think it's good.
Okay. So then, well, maybe we can get some board working on Tuesday also. Throw up a couple problems, we can go to the boards and try that. The test is, I don't think it's real bad, I really don't. I'm gonna do it with work again, obviously, that worked pretty well. The first part of the test has to do with just functions versus relations, right? So, you know, a bunch of these really, I think, really easy questions, you know, just yes or no, are these functions or not? So let's just go down the list and look at each of these, and you tell me, is that a function? It is, good, how come? Okay, good, each input only has one output, good, so that one is a definite yes. How about this guy? Nope, what's the problem there? Okay, good, look, the input 10 has two different outputs, so that one's a no. How about this one? No, what's the problem here? 10 again, yeah, the 10's having a bad day. The 10's got, notice it's got two different output values, right, so that's a no. How about this guy? Okay, that one looks pretty good, doesn't it? If we sweep a, maybe we'll grab that thing. If we sweep a vertical line across this, it never intersects in more than one place, does it? So it passes the vertical line test, so we're good. That one is a function. Okay, there's gonna be a question or two that's gonna ask you for a discrete set like this. It might give you a set, it might give you a map, thank you. It might give you a, you know, a scatter plot. Could give you any of those kinds of things. Could be a table. I just want you to be able to write the domain and the range and then tell me if it's a function or not. So I'm gonna change this. Let's make that a negative also. So what's the domain gonna be for this one?
2, 5, 7, 9.
Good. And we want to write it using set notations. We've got to use the script brackets. We've got to put them in order. 2, 5, 7, 9. How about the range?
2, or 6, 8.
Okay, I get -6. Do I have to say it twice? No, just once. -6, -3, 2. Okay, is it a function?
Yes.
Yes, it is. Okay. Good, you can see that there's only one output for each input. Okay, so moving on to the continuous function graphs. So talk to me about this one. What's going on there with the domain? How about?
All reals,
All reals, good. And why? How come?
because it goes infinitely.
It would keep going forever, wouldn't it? If we zoom out, this thing's going to keep going to the left and the right forever. Okay? So yeah, we know that this one, it's going to keep going that direction forever, and it's going to keep going that direction forever. And so, the domain is what? If I want to write it using inequality notation, how do I say all reals? Yeah, you bet. Yeah. That's just, right, capital R. Okay. What about the range? What about the range? Okay, so it's got a bottom limit of -2 and a top limit of 6. Do we include those?
Yes.
Yes, we do. Okay, so then the range would be y is greater than or equal to -2 and less than or equal to 6. Good? Okay, is it a function? Yes, it is. How come? Passes the vertical line test, right? Vertical line would never intersect this at more than one place, so we're good. It is a function. Okay, how about that one? Let's check the domain. So that's x values, right? Gabe, what do you think? Is there a lower x value and an upper x value this time? Yeah, there is, right? So this one doesn't go forever, does it? What's our lower limit for the x's? Everybody see that, -8? Okay, because it looks like that's the furthest we get to the left. What's the upper limit? 6. And then is that going to be, do I include that point? No, I don't. So that would be an open circle, and if we wanted to graph the domain, it would just look like that green graph, wouldn't it? So how do I say that as an inequality? X is
Greater than or equal to -8.
greater than or equal to -8, because we are including -8, and
Less than 6.
less than 6, but not equal to, right? Because we're not including the 6. Right, there's actually not a place on the function where x equals 6. We get right up close to it, but we never actually get to 6, do we? Okay, what about the range? -5 up to 2, right? Because we can see that here's a point right here that actually has a y value of -5, and here's a point right here that actually does have a y value of 2, right? This one doesn't have it, but this one does, right? And what's the test? As long as there is a place on the function with a y value of 2, we have to include it, right? So then our range, if we wanted to graph it, it would just be that red graph, wouldn't it? So how would I say that? Y is what? The range is y. Greater than or equal to -5, and less than or equal to 2. Good. Okay. Yes, ma'am. Yeah. Is this a function? Yeah, it is, right? Right, passes vertical line test, so we're good. What about this guy, domain? So the domain, x's or y's? X's. Okay, Kaylee, is there a bottom x value on this function? Negative, well, it's hard to see, but it looks like it's, let's see, what is that, if I go straight down? -2?
Oh.
Yeah, so -2, and do we include that? We do, good, because there is a place right here that actually has that value, right? So we'll include that x value. What's our upper limit? 8, okay, right here. Do we include that one? No, open circle, so we don't include that one. And so there's a graph of our domain. How would we say that one? X is greater than or equal to -2 and less than 8. Good. Okay, what about the range? Jaylene, is there a lower limit and an upper limit for the y's? What's the lower limit going to be? 0. Good. We can see that here's a point right there that has a y value of 0. Upper limit would be 10. There's a place right there that actually has a y value of 10. And then every place in between, all those y values would be included, right? So, Mackenzie, how would I say that then? My range, y is what?
Greater than or equal to 0.
0, good. And less than or equal to
10.
10, very good. Okay, we're looking at the y values there. Good. Is it a function? No, clearly not. I mean, in fact, there's a vertical line right there. We can see it intersects it in 2 places. So it fails the vertical line test. So this is not a function, right? Okay, so now what about this stuff? So here's where we just have to understand what it means to evaluate a function, right? So we've got this function they're defining for us, f of x equals 2x plus 1. And we want to know, what is f of 1/4? Well, what does that mean, f of 1/4?
It just means that the x is 1/4.
That the x value we're plugging in is 1/4, right? So then f of 1/4, it means, what does it mean then? It means x is 1/4. What does f of 1/4 stand for?
What would be the answer if x is 1/4?
Okay, what would be the value of the function if x was 1/4. If I plug that in, I'm gonna get back a number, agree? Whatever that number is, that's f of 1/4. It's the output number. That just means a number. It doesn't look like a number when you look at it, but it just means a number, right? So what do we get when we plug it in? Well, we're gonna start with f of x. And remember what our little trick is then. When we want to plug something else in, every place we have an x, we just open up a set of parentheses. And whatever number we're plugging in this case, 1/4, that's what we put inside the empty quantity where the x goes, right? We're dumping a 1/4 into our function here. What do we get? So what's 2 times 1/4? Yeah, that'd be 2/4, which is 1/2, plus 1, well, 1 is 1 over 1 is a fraction. When I add or subtract fractions, what do I have to get?
A 1.
Common denominator, right? You gotta have a common denominator to add or subtract fractions. So what's my common denominator gonna be here? 2. So I gotta multiply, this one has a 1 on the bottom, so I gotta multiply both the top and the bottom by 2. And then what's that give me? That gives me 1/2 plus 2/2 equals, how many halves? 3, right? Because I keep the denominator stays the same. And I'm just going to add the numerators in this case. I get 3/2. Whoops, that's supposed to be a 2. Like I said, the denominator stays the same. Right, so we end up with 3/2 is our answer. Now, what's that mean, though? So it's just a number, like we said. When I input an x value of 1/4, what is this? That's the output of the y value, isn't it? So if I want to write this as an ordered pair, I could write the ordered pair, x is 1/4, y is 3/2. That would be those would be the coordinates of a point on my graph, right? Okay? Okay, speaking of graphs, super easy question, right? What is this saying here? Based on the graph, f of 4 equals blank. So we could paraphrase this question. We could say this maybe more easily. Just restate the entire question by saying something like, is 4 an x value or a y value? X value, right? So it's just saying when x equals 4, f of 4 is the output, right? So that's the y value. Y equals, you fill in the blank, right? What does a graph do? I think all a graph does is it connects x and y using a really helpful visual pattern. That's all it's doing. It's connecting the x values, the input values, and the output values, right? So if I want to figure out what y is when x equals 4, where do I look? At x equals 4, right? Every place on that line has an x value of 4. So where is the function then when x equals 4? Yeah, the function has coordinates x equals 4, y equals 0, right? And so our answer is 0. Whatever the y value is that goes with the x value 4 on our graph, right? Easy. Okay. And then this question is just kind of the reverse, isn't it? It's saying solve the equation, f of x equals 2, x equals what, right? Well, how would we restate that one? Say it again, when, or what? What are we looking for here? X. What are they telling us? When, okay, when y equals 2, x equals, fill in the blank, right? So where does y equal 2? Well, y equals 2 every place on that horizontal line, doesn't it? Right? Aren't those all the places where y equals 2? And so we've got 2 solutions here, don't we? We get a solution there. What are the coordinates of that place? 0, 2. And then what about this place right there? or 2. So what are my solutions then? We want to know all the x values where y equals 2. And so I get 0, comma. It says just separate solutions with a comma if we have more than one. So 0, 4, right? Mistake. Okay. All right, so what about this stuff then? Now, people seem to have a hard time with this, but the reason people have a hard time with this is they're trying to make this out to be more than it is. Okay? What is 2 times f of 9? Well, what's f of 9? What's that mean?
If x equals 9, y equals,
Y equals blank, right? So it's going to be the output number when the input number is 9. But that's just some number. That's all it means. It's just a number, right? So I'm going to get 2 times whatever that number is. Now we have to calculate that number, but once I find it, I'm just multiplying a number times 2, right? So what is that number? Well, we can find it. We'll use our same strategy of f of x equals negative x squared plus 5x plus 6. And I want to calculate, what is f of something. Well, every place I have an x, I'm just going to open up an empty set of parentheses to dump in some value. So what value am I plugging in? 9, right? Okay, so where I used to have an x, I've got 9s. So let's simplify this then. What am I going to get from this term? I'm going to get 81 is 9 squared times negative 1 makes it negative. And I got to follow order of operations. So I have to do the exponent first, right? Don't make the mistake of thinking this is negative 9 squared. It's not. It's 9 squared negative, right? We have to do exponents first. So we get negative 81 plus what, 45 plus 6. Well, those two add up to 51, don't they? So that makes this negative 81 plus 51 is what? Yeah, good. Negative 30, right? So if that's f of 9, then what's 2 times f of 9? 60. Negative 60, right? That's all we're doing here is just 2 times negative 30 equals negative 60, right? So I'm even gonna have, on the test, the way it's, I just wrote it, and so it goes through in order, and you can't, you can only do things sequentially on it, right? And I've got this one set up so you have to just go in order. You can't skip forward, you have to do the question before you move on. So the way this is gonna work then is you'll have like a basic, Desmos basic calculator for the first, I think, 9 questions. And then after that, you'll get to a point where now you can start using the scientific calculator. And so a problem like this, I'm even gonna let you use a scientific calculator. Okay. So we could even, let's do this bottom one with the Desmos scientific calculator. All we'd have to do for this one, like for this bottom one, well, you tell me, what do I do? Oops. You tell me, what do I do? If I want to do that one using...
f of x equals...
Okay, I got to define the function. Oops, f of x equals negative 5x minus 14. Now what?
And then we do the f of 1 minus...
Okay, I could do f of 1, and I get a number, negative 19, right?
Mm-hmm.
And if I do f of negative 10, I get another number, right? So really this is just negative 19 minus 36. And I can even do this. I could even say f of negative 1 minus f of, it's supposed to be 1, isn't it? F of 1 minus f of negative 10. And it'll even tell me, right? It tells me what the difference is. Okay, you have to just define the function first. What I'm really wanting you to know about this is just that f of a number is just a number, just an output number. Okay? Oops. Let me take a picture of that for the notes. Okay? Okay, so what about this? What's this saying?
Then f of x equals 2, then x equals, right,
So what am I gonna do here? What's this asking me to do algebraically then?
you're finding 2 for f of x.
There you go. It's defining, whoops, it's defining f of x equal to 2. So I'm just gonna replace the f of x with a 2. I'm gonna substitute and then solve. Well, what are the 2 steps in order to solve for x?
Minus 6 and divided by 2.
Yeah, so if we just subtract 6, we get -4 equals 2x divided by 2. And what do I get? -2. Yeah, no big. Okay, write the linear equation in standard form. Okay, in standard form. You know what, I think I might even on the test, I'll add those 4 questions just for some freebies for you. Add those 4 questions about, you just gotta memorize the 4 formulas for this chapter. Super easy, right? You gotta know them. So what is standard form? Plus by equals c, good, okay? And what can you tell me about a, b, and c? What's the first thing you know? What kind of numbers are they?
Integers.
Integers, right? Can't be fractions, can't be decimals. They have to be integers. What can you tell me about a? Positive. And then probably the hardest one, what's the greatest common factor of a, b, and c? Has to be 1, okay. So we gotta do that stuff. We gotta rewrite this equation so it meets all 3 of those criteria. So the first one is just what does this look like? Well, we gotta have the x and y terms on the left and the number on the right, the constant on the right. And so what am I gonna do to make that happen? Let's see what this is. What am I gonna do? Okay, I gotta add 6, get the number over there, right? That's one thing I gotta do. What else? Almost. Subtract 12y. Okay, and that's gonna do the job, isn't it? Then I'm gonna get those guys cancel, those guys cancel, and we get what we want. We get the x term and the y term on the left. On the right side, 15 plus 6 is 21. So let's check. Where are we here? Step 1, check. Right, we got integers for a, b, and c. Is a positive? Yeah. Okay. Is the greatest common factor of a, b, and c 1? Ah, what could I divide all the numbers by? 3. Okay, good. I could divide everything through by 3. So if I divide everything by 3, what's that really mean? Well, that just means I'm dividing each term separately by 3, right? And what's that give me? 10x minus 4y equals, now we're good. Now we hit that last one, didn't we? Right? Okay, yes, sir.
What do you try that?
Okay, so that means that the greatest common factor, let's review what that even means. I go back to the algebra 1 for a second. Greatest common factor means greatest means biggest, common means shared, factor means something that divides into it, right? So we want the biggest number that divides evenly into A, B, and C has to be 1. See, right here it wasn't. Right here, 30, 12, and 21 are all divisible by 3. So I gotta divide both sides of the equation by 3 to simplify those numbers to make them smaller. But now we get down here, 10 and 4 and 7. Well, okay, now there is nothing that divides into all 3 of those other than just 1. Okay? That make sense? Okay? All right. Write the linear equation in slope-intercept form. Okay, well, first of all, what is slope-intercept form?
Y equals mx plus b.
Okay, good. So we know we're trying to get to this form. Y equals mx plus b. And really all that means is, we're just gonna isolate y and simplify, right? So what are the steps over here then to get the y by itself?
Add 2x.
Okay, first step is we gotta push that other term, the x term to the right side. So we'll add 2x to both sides. So those guys cancel. And I get negative 11y equals, which term first, x or 4?
X.
X. So we get 2x minus 4, now what? Divide by negative 11, good. And so when we divide both sides, it means we're going to divide everything by negative 11, right? Yeah. So what's that give us? If we simplify this then, negative 11 over, that cancels the negative 11. It gives us our y by itself, which is what we wanted. Now what about here? We're just focusing on, right, we're just focusing on the coefficient of x, just the fraction part, right? So positive over negative is negative, and then does 2/11 simplify? No, we can't reduce that, right? So we're stuck with a 2/11 times x, and then what about here? Negative over negative is positive, and then can I simplify 4/11?
No.
No. So there's my answer, right? Got it in slope-intercept form, okay? Okay, so what about this then? Now we want to graph a function that's in slope-intercept form. Now on Moodle, you're going to get like 8 choices. You got to pick the right one. Well, what's that mean? In order to pick the right one, you got to know how to graph it, right? So how would we? This is a really simple one to graph when they're in slope-intercept form. What's our strategy here? Start at 6, right? We know that the y-intercept is 6, and so there's an anchor point. And now what? Ah, okay, good. So we see that the slope is 2, which is the same as 2 over 1, right? So we can rise by 2, run by 1. That gives us another point. And so now all I've got to do is just, connect and extend, and there's our line, right? How would we pick the line in Moodle, though? The easiest way would just be to pick the one line that goes through those 2 points that we identified, right? All the other ones are wrong. Only one line in the universe that goes through those 2 points, and that's the one you want. That'll be one of the choices. Okay, finding intercepts. So what's our, we're given a function in standard form here, or not quite in standard form. It's not really correct standard form, is it? We're given some function, some linear function, and we want to find the x and the y intercepts. What's our strategy, Joe, what's our strategy for finding the x-intercept? What are we going to do? Now when we're finding, we're supposed to write it as an ordered pair. Well, here, I bet you do know this part, right? Because this is the strategy. When I'm finding the x-intercept, what's the y-coordinate? 0, right? Because if it's on, the x-intercept means it's on the x-axis. The x-axis is where y is equal to 0, right? So we know before we even do anything, we can already fill out that coordinate is 0. We're just trying to find the x-coordinate, and there's our strategy. When we're trying to find the x-intercept, really, we've got 2 steps. We're going to set what? For the x-intercept, we set y equal to 0, and solve for x. That's it, right? So if we set y equal to 0, here's our equation. If I set y equal to 0 in our equation, and let me rewrite that. So our equation looks like negative 5x minus 10y equals 5. If I set y equal to 0, what does that equation become? Yeah, I just cover that term up, don't I? Right? And so I just get the equation. I get the simple equation, negative 5x equals 5. What's the one step to solve for x? Divide by negative 5. And what's that give us then? We get negative 1 for our x value. Okay? If I'm trying to solve for the y-intercept, what's our strategy there? I'm going to set x equal to 0. Good. And solve for y, right? So we end up with x is equal to 0. Now I solve for y, right? So if I solve for y, I'm setting x equal to 0, well, what's that give us? We get negative 10y equals 5. I'm just covering that term up. One step to solve for y. Divide by negative 10, and I get y equals negative 5/10, which is just negative 1/2, right? There we go. Escape. Right? Okay, so then what about a problem like this, where now we're given an equation that's in standard form, and we want to graph this thing. What are our options? Well, we could always just put it in slope-intercept form, right, and then graph it from there, and that's fine. I mean, you can kind of almost take a pick here, whatever's most comfortable to you. So if we want to solve this thing for y, what would the two steps be to solve for y? Subtract x. Okay, so we're going to get negative 2y equals negative x plus 6, right? And then what? Divide by negative 2. Okay, so divide everything by negative 2. And so we're going to get y equals, and then here we just want the ratio of the coefficients, right? So negative 1 divided by negative 2 is, negative over negative is positive, just 1/2, right? X, 6 over negative 2 is minus 3. So there would be my equation in slope-intercept form, right? So Dominic, how am I going to graph that? Okay, I'm going to start with a y-intercept of negative 3, and what am I going to do? Up 1 over 2. Plus 1, up, plus 2 over, and I get another point right there. And then I just connect and extend those, right? Okay, what could my other strategy have been, though? All I need are 2 points, right? So what would 2 easy points to find have been here? I could just find the intercepts, too. That could be my other strategy, right? I could find the x-intercept. What's that going to be? X-intercept is where y is 0. So if I set y equal to 0, that's pretty easy. What do I get? 6. So I get the point over 6.
Attention, teachers, please release band members who are participating in the flag raising ceremony at this time so they can get prepared.
Okay. The band members, go off you go. All right. So we got the point 6, 0, right? So there's my x-intercept. And then what about the y-intercept? Y-intercept is where what is 0? X. So if x is 0, that's pretty easy too. Divide by negative 2, and what do I get? Negative 3. Okay. And I think we already did that one, didn't we? That's right there, right? Either way, look, I get these points that line up. Doesn't matter. I just need 2 points. So either method's going to give me 2 points. Then all I have to do is just connect and extend those points. Let's see if I can get this right here. Okay, that's close. You get the idea, right? Okay? All right, let's see if we can do, maybe just, what are we at here, 40? 40. Okay, let's just do one more. Then we'll pick the rest up on Tuesday. So what about this one? We can just look at this. There's no work to do, right? We can tell just by looking at those whether those lines are parallel, perpendicular, or neither. It's neither. How come?
Because the slopes don't match.
The slopes don't work, do they? Yeah, it's the slopes. What we're looking at here are just the slopes. So this top one has a slope, because it's in slope-intercept form, right? It has a slope of 3/2. Bottom one has a slope of negative 1/6. Well, what would the bottom slope have to be for the lines to be parallel? To be parallel. It'd have to be 3/2, right? Because parallel slopes, we know, or parallel lines have equal slopes. What would it have to be for the lines to be perpendicular?
2/3.
Negative 2/3, right? Because we know that perpendicular lines, the slopes are negative or opposite, whatever you want to say. Negative reciprocals. So we got it, one's positive, one's negative, and they're the flip of each other, right? And then if neither one of those is true, like in this case, it's neither. So what would the top slope have to be? If the bottom one's negative 1/6, what would the top one have to be perpendicular? Positive 6, right? Okay? Good. Let's see. Oh, we can do one more. This is such a quick one. This is a really quick one. So you tell me, first of all, what is point slope form?
Y minus Y1 equals, M multiplied by
Times x minus x1. Good. Right, so all we're doing for point slope form, all we're doing is just plugging in the right data, right? So, and that's how they want this one left. You don't have to hardly do anything here. You're just plugging the stuff into point slope form. So what would we get in this case? We would get y minus, okay, so that's gonna make that a y plus 7, right? Equals, whoops. I get so excited, I just start writing too fast, you know? That's how exciting math is. Times x minus, okay, makes sense? And that's how we leave it, right? That's our answer in point slope form. Okay, call her a day?